Chapter 10. This is the last chapter for you guys. So I figured that I would end on something that's not really related to algebra, but it's still a really good skill to have, especially if you're interested in things like your grades, or if you're interested in sports and statistics and things that people look for sports-wise. A lot of people are very interested in sports, and so they're used to the statistics of their sports, like the passing rate or interception rate for football, even the throwing rates or the running rates for baseball or softball. So statistics and probability are really, really useful things. So we're just going to start off with just some basics, and I'm going to have you guys do some more real-life examples for it later. But for right now, we're going to get started with just some key vocabulary. The first word that you need to be aware of is probability. Probability is just the likelihood of an event occurring, and this can be related in a couple of different ways. Typically, it's related between 0 and 1. So if you have, let's talk about football, if you have a quarterback who has a really good passing rate, people might ask, well, what is the probability, what is the chance of that quarterback making or having an interception on his pass? Well, if he has a really high passing rate, well, then that means that he would have a very low chance of having his passes intercepted. Obviously, I understand there, each team is different, and the quarterback may be really good, but all of a sudden they're playing a different team, so therefore, the statistics are going to change. I understand that, but I'm talking about in like a perfect world. If they have a pretty high success rate, then that means interceptions are going to be a low chance, okay? So sometimes this can be written as a percentage. So let's say there's only a 10% chance of this quarterback having his passes intercepted. Well, then we would say, if we wanted, we could say 10%, all right, is equal to 0.10. Okay, that is the decimal form. So you can write it as a decimal, or you can write it as a percentage. And we have this nice little scale here, and I'm going to go ahead and just put a little bubble around it so you can see. And we can notice that 0.10 or 10% is very unlikely. It's actually in between impossible and unlikely. So this is a very small percentage or a very low chance of this occurring. There's also some other vocabulary down here. They're talking about like probability experiments, which is basically you doing the actual thing. So let's say we want to find the statistics of rolling a die, like some dice or something. Then you would actually have to roll the die. That's an experiment. You're doing it. Outcomes, what are the possible outcomes? If you're rolling a die, you can either get a 1, a 2, a 3, a 4, a 5, or 6 for a 6-sided die. The event is just a collection of one or more outcomes. So we could say, well, what's the probability of an event of getting a 1 or 2? Okay, that is one of the outcomes. Or if we're looking for 1 or 2, that is a collection of 2 outcomes or an event. So the most important thing I need you guys to know from this section are the sample space and outcomes, though. Sample space is a set of all possible outcomes. And the reason I need you to know that is because this is always going to be your denominator, your sample space of what all the possibilities for each event. This is going to be really key in what your denominator is going to be. So you have to make sure you understand this piece. And then I went ahead and highlighted outcome as well, because the outcome is going to change, but this is always your numerator. So we went ahead and included just a quick picture so you can see the experiment or the probability experiment or the situation. You could be rolling a number cube or die, a 6-sided die, or you can be spinning a spinner, okay? Obviously, these are just 2 possible experiments or 2 possible situations that you might come across. Another really common one is you have a a deck of cards. So these are what you could be doing, the probability experiment. And then the sample space, well, what are the possible outcomes? All of the possible outcomes. Well, for a die, you have 1 through 6 as possible outcomes. That's 6 possibilities in the sample space. And then for our spinner here, we only have 4 colors. If we had more, well, then our sample space would increase because we would have more things to include in our sample space. But in this particular case, we have red, yellow, red, and green colors. So if we spin the spinner, we have those 4 possibilities for our sample space. So we would say our sample space equals 4. So example 1 says, list the outcomes and the number of possibilities or the sample size. So that's what we're going to do. We're going to look at each situation and we are going to list all the possible outcomes or the sample space. And we are going to do this, we can either list it out sort of just like from our memory, or we can sort of organize it and make a sort of tree, if you will, and it's called a tree diagram specifically. So for example, 1.1a on the left-hand side says, you flip a coin and roll a 6-sided die. So the first thing that we have to deal with is our coin. We have 2 possibilities. We have either heads or we have tails, okay? Those are the only 2 possibilities. Well, what if we got a heads? Afterwards, when we are done flipping the coin, we will take our die and we'll roll it. And from there, we have 6 possibilities. We have our die 1 through 6. And the same thing for our tail. If we get tails, we still have 6 possibilities after we get a tail. So I'm going to put 1, 2, 3, 4, 5, 6 here. And I'm just going to show that these are our next possible outcomes. All right, so I'm just drawing these. All right, and now that I'm done with that, I can go ahead and list my possibilities. I could either get a head. I'm just going to put my little bracket, my curly bracket. Remember, curly bracket is a list of items, just like in Chapter 8 when we had a list of numbers. I told you to use a curly bracket. So in this particular case, it's not always numbers, it's items. Heads, tails. I think in the previous one we had like red and blue. So we're going to just do the same idea. We'll just put a comma in between the stuff. So I could either get a heads and then 1, or I could get heads 2, head 3, heads 4, heads 5, or heads 6. Those are the possibilities that I have if I were to get a heads first. So then I can look at tails. What if I get tails? Well, I could get tails and then 1, a tails and then 2, tails and then 3, tails and then 4, tails and then 5, tails and then 6, and that is it. So I can put my end curly bracket, and I've listed all of the outcomes, or I've listed my sample space. And then I'm just going to count all these up. And I sort of separated them I just to organize my information a little bit easier, just so that I can see things. And when I do it this way, it's really easy because I have sort of a rectangular shape, and so I can just count how many I have on top and how many I have on the side, and I can multiply those two. So I have H 1, 2, 3, 4, 5, 6. That's 6 possibilities at the top, and then H and then T. That's 2. So 6 times 2 is 12. All right. So I have 12 possibilities when I flip a coin and roll a 6-sided die. And that's all we're doing here. We're just listing out our possibilities. Remember, when we do this sort of tree diagram, it's just to help us organize our information. Our answer, though, is from our curly bracket to the end of the curly bracket, and then we write how many possibilities was inside of our sample space, which in this case was 12. So our answer, just to make sure that you guys are understanding, is technically all of this. Okay? All right, so let's go over to the right. List the outcomes and the number of possibilities, or the sample size, when you flip 2 coins. Okay, so this one's going to be a little bit shorter. We'll have coin number, let's say coin 1, we can either get heads or tails. And then coin 2, we can either have heads or tails, or heads or tails. Coin 1, coin 2. Okay, so now I can write my sample space. So I can do heads and then heads, or I can do heads and then tails. And then if I go over to my right-hand side, my right tree, I got tails and then heads, or tails and then tails. So then that's it. Those are the only possibilities. So I'll put my end curly bracket, and I will count how many is inside of this sample space, which is just 4, and I'll say equals 4. And that is our sample size. So please understand that the 12 and the 4, that would be the denominator of our fraction in a couple of minutes. All right, let's continue on. I wanted to do at least example 1.1b on the bottom left. It's you flip 2 coins and roll a die. This is the same idea, but it's just getting longer and longer. So the more things you add to your event, remember your event or your experiment is what you're doing, the more possibilities you are going to have. So this one says I have to do 2 coins. So I'm going to copy down the same tree as I did in green. All right, I'm just going to copy that down. And after I'm done with that, I'm going to, under each one of my possibilities, I got 4 possibilities on that sort of row right there, I'm going to add my die, which is 6 possibilities, 1 through 6. So it's be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1 through 6 again, and then 1 through 6 again. Okay. All right, so I got that. Now I'm going to start listing my possibilities. So I can have the first 6 are all going to be when I roll a heads twice in a row. So I'm going to say this is going to be H, H1, and then I have H, H2. And just to make sure you understand where I'm getting these possibilities, I am sort of imagining it as I start here, and I happen to get this event next, and then I got the 1. Or, again, I start here, and then here, and then I go to the 2, all right? And then heads, 3, heads, 4, heads, 5, heads, 6. All right, and then after I'm done exhausting all of those, I move on to the next piece. So let me just catch up and write all of this really quickly. Head, 5, head, 6. All right, so then the next piece is now I'm still starting at heads. But now I'm going to tails and then 1. And then I'll do heads, tails 2, and then heads, tails 3, head, tails 4, head, tails 5, head, tails 6. So I'm just writing all these possibilities. So heads, tail 1, heads, tails 2, heads, tails 3, heads, tails 4, heads, tails 5, heads, tail 6. All right. And now that I'm done with all of the left-hand side where I start with the heads, now I'm going to go to when I have I start off with tails, so it would be tails, head 1, tails, head 2, tails, head 3, 4, 5, 6. So I'm just going to write all those possibilities. 1, 2, 3, 4, 5, and then 6. And then finally, after I'm done with that, I can do my final piece, which is going from tails, 1, tails, 2, tail, 3, tail, 4, tail, 5, tail, 6. So I'm just adding doing the final possibilities. And again, I'm sort of having new paragraphs, if you will, to make sure that we keep our information organized. All right, and so once I'm done with that, I can count how many I have. Again, you can, since I sort of kept all my information organized, I can just multiply my height and my width. So I have 4 on the side and I have 6 on top. 4 times 6 is 24. All right, so I have 24 possibilities as my sample space, and that would be my denominator. All right, so then the last one is you have a deck of 4 red cards and 4 white cards and 4 blue cards, all numbered 1 through 4. So you have 1 red, 2 red, 3 red, or if you want R1, R2, R3, R4. And so I'm gonna start with the colors first, just because there's fewer colors. So I'm gonna say red, white, and blue. And then within each of these colors, I have 1 through 4. as a possibility for the color. So now I can put my sample space. My sample space is going to be R1, R2, R3, R4, and then I can go to the white or W1, W2, W3, W4, then I can go to B, B1, B2, B3, and B4. Okay, let me put my little curly bracket. I can count these up. It's a 3 times 4, which is 12. And this is my sample space. Okay, so please make sure that when you're doing this, you are trying to keep all your information organized so that way you don't accidentally skip some. And I did make a mistake when I was, not in this particular example, but while I was doing the notes, I was not keeping my information organized and I accidentally skipped a couple of items. And I made sure that I didn't do that while I was showing you this video, but when I was doing it on my own, it was, and I teach this, it was possible that if you don't keep your information organized, you can skip accidentally some possibilities, and therefore your sample space will be wrong. So just please keep that aware, just in your head of, as a possibility, and just be extra careful. Try the tree diagram so it can help you keep your information organized, and just make sure that you are writing everything out clearly, add some paragraphs if you need, and then make sure you count correctly. So theoretical probability, you can imagine theoretical probability being if we were in a perfect world. This is the number of outcomes over your sample size. And sometimes people would say this is like the number of outcomes or desired events, and they would put it over the total number of the outcomes. So actually I'm going to change events into outcomes really fast. Outcomes. All right. So we would say what we're looking for, the number of desired outcomes over the number of total outcomes. So again, the bottom is our sample space or sample size. And an important thing to know about this is that the sum of all outcomes is going to be equal to 1. That is something you should definitely know just in general. It's a really good piece of information to know. So for example, if we had a die, remember a 6-sided die, we have the possibility of getting 1, 2, 3, 4, 5, or 6, okay? So when we are trying to figure out what is the probability, what is the chance of getting a 1, well, that's 1 out of 6 chance. And then I'm going to add that to the possibility of getting a 2. Well, to get a 2, that's still a 1 out of 6 chance. A 3 is a 1 out of 6 chance. And all of the numbers are a 1 out of 6 chance. After you're done writing everything, you're going to add everything up, and this is going to equal 6, because 1 plus 1 plus 1 plus 1 plus 1 is 6 over 6. And 6 over 6 equals 1. All right, so the sum of all the possibilities is going to equal 1, and typically we're not going to be doing that. Typically we're just going to be looking at the one desired outcome that we're looking for. We want to roll a 4 or whatever it may be. So example 2 says find the probability of the following scenarios. And I'm actually going to start with 2.2, which is on the right-hand side. It says you flip a coin and you roll a 6-sided die. What is the probability that you got a tails and a 4? So this one is, I'm just going to, we've done it before, so I'm going to just copy down the information that I've already found. So we start off with our coin. We have heads or tails. Then we go to our die. Under heads, we can have 6 possibilities, and under tails, we have 6 possibilities. From here, I'm going to write my sample space, H1, H2, H3, H4, H5, H6, H7, and then I'm going to go to tails and write all that as well. All right, and then once I'm done with that, I can sort of just set up my probability in my head. Remember, it's going to be our desired outcome in the numerator and our sample size in the bottom. And remember, our sample size is the number of total outcomes, the number of total outcomes. And then our numerator is just what we're looking for. And in this particular case, we're looking for one thing. We're looking for T4. And so in my list, I only have one of those events. So I'm going to say it's 1 over, and then my total is going to be all of the possibilities, which in this case is 12. So I can keep it as a fraction, but I would like to express it as both a decimal and a percentage. So I'm going to type this into my calculator. I'm going to get 0.083 repeating. If I wanted to turn it into a percentage, then it's going to be approximately 8.3%, and this is my answer. Okay? So then the reason I did that one first was because we've basically set up the majority of it already from example 1. Now, example 2.1 on the left-hand side, it says a student taking a 4-question true or false quiz guesses at each problem. What is the probability that the student got exactly 2 questions right? All right. In this particular case, the tree is going to be a little more complicated. So what I'm going to do instead is I'm going to do a table with this one instead. So I'm going to, in my first column, because I'm looking for things that are correct, I'm going to say the possibilities of getting things correct. Well, they could get 0 correct, they could get 1 or 2 or 3 or 4 answers correct. This is, I'm doing everything. I'm doing my sample space right now. And so I'm going to label this column as the number correct. All right, and then I'm going to extend my lines so that I can put some information, and I'm going to go ahead and put the possibilities. Well, if I have 0 correct, that means 1 is incorrect, 2 is incorrect, 3 is incorrect, and 4 is incorrect. All right, now I'm going to go to 1. Well, I could have, I'm going to do 4 correct because that's only one possibility. I can get all of them correct. All right, so I'm just doing the easiest one first. Now I'm going to go back to 1. And 1 is going to be, I could either have the first one correct and the rest are wrong. I could have the second one correct and the rest are wrong. The third one's correct and the rest are wrong. Or the fourth one is correct and the rest are wrong. If I have only 2 correct, then I can, I think I'm going to start with 1 and 2 being correct. So I'll say 1 and 2 are correct and the rest are wrong. All right. I could move one of my checks over, and then it would be numbers 1 and 3 are correct and the rest are wrong. I could have 1 and 4 correct and the rest are wrong. I could have 2 and 4 correct and the rest are wrong. Or I could have 3 and 4 are correct and the rest are wrong. And then I can have the 2 middle ones, 2 and 3 are correct and the rest are wrong. Okay, so all I'm doing right here, again, is I'm just listing the possibilities. And I changed it from a tree format to a table format because it was going to get a little hard to read, a little hard to, I personally think it's a little hard to read, but I'll show you what the tree would look like in a second. So then the number of correct, if we had 3 correct, that would be all of them are correct except the last, all of them are correct or except the third, all are correct except the second, or all are correct except the first. All right, so I can't think of any other possibilities, and this is actually the one that I started off with, that I said earlier, that on my own, I made a mistake and I had the incorrect sample size, and it was because I tried the tree diagram, and for some reason, it just did not work for me, and I missed out on some outcomes, and so I did the table as sort of a backup, and I thought it was a little bit easier. Again, I'll show you the tree diagram just to make sure that you guys can compare and see is that better for you. All right, so now that I have this, I'm not going to write my sample space because it's going to get really crazy with all my X's and check marks. So I'm just going to go ahead and set up my fraction. Remember, it's 2 correct answers or 2 right answers over the sample size, which is your total number of outcomes. And now I'm just going to count. I can see that I have 16 possibilities in total. And then if I just go to the row where 2 are correct, I have 1, 2, 3, 4, 5 possibilities. So, or actually 1, 2, 3, 4, 5, 6, 6 possibilities. So I'm going to write 6 here. 6 over 16 is going to be 3 over 8. And if I type that in my calculator, it's going to give me 0.375 or 37.5%. And again, just to make sure you guys remember how to turn a decimal into a percentage, you take your decimal and you move it over to the right 2 times, and then that is where you are going to put your percent or your decimal for your percent. And so the same thing happens on the right hand side with the 0.083. We have our decimal, we move it to the right 2 times, and that's how we got 8.3. So that is this. So let me show you the tree diagram really fast. All right, so I can set up my problems first. I can say I have 1, 2, 3, and problem 4, and then for each one of them I have the possibility of having it either correct, so I'll put C for correct, or incorrect, so I'll put I for incorrect. So that's the possibilities for all of my numbers. And then after this, it gets a little crazy. So it's really hard to show a tree diagram for this problem, which is why I missed a couple of my possibilities and why I had to switch over to a table. But it's really hard to be like, oh, I could either have number 1 is correct or incorrect, number 2 is correct or incorrect, number 3 is correct or incorrect, 4 correct or incorrect. Okay, so I can see all of this. All right, but that gives me 1, 2, 3, 4, 5, 6, 7, 8. That gives me 8 possibilities. All right, and I needed 16. Okay, so I'm missing half of my information, which is why the tree diagram in this case does not work. So the complement of an event is going to be written as A bar, and so it'll say the probability of the complement or not the event is going to be equal to 1 minus the opposite of the event. So in this particular case, and I didn't write the instructions, I meant to, but in this particular case, it's asking us to find the probability. When you roll 2 die, what is the probability that the sum of the 2 dice is going to be, it does not equal 6, okay? And so the complement of an event might seem a little weird or a little dumb, but actually the purpose of the complement is to help us, instead of trying to find the data of a lot of things, we can find the data of just a few things, and it makes our work shorter and easier. So, for example, the probability of the sum does not equal 6. Well, if I were to look at these, 1 plus 1, there's first, or snake eyes, if you will. There's 2 snake eyes, add them up, you get 2. That does not equal 6. So that could be, or that is one of the outcomes that I am desiring to have. And the next one, 2 plus 1 is 3. 3 plus 1 is 4. So I can see that all 3 of those are possibilities, and I actually have a lot of possibilities here. And so because I can sort of see this as, well, there's a lot that's going to be possible for the numerator, then that means if I were to look for the opposite of that, when the sum does equal 0, so I'll say 1 minus the probability of the sum when it does equal 6, all right, that is going to be a lot shorter. So what I'm going to do first is I'm actually going to add up my 2 dice and just put that number below each one. So this will be 2, 4. Okay, so I'm just adding all these up, and I can sort of see a pattern arising. If you look, you can sort of see that your numbers are the same diagonally. All right, so I'm just adding all of these up. Give me a couple more seconds, and then finally 12. Okay, so now I can go ahead and I can see very easily that there are a whole lot more that do not equal 6 than do equal 6. And if I were to find my do equal 6, that is going to be shorter because I have fewer of those possibilities. All right, so I'm just going to highlight all of the dice that add up to equal 6. So I got these 1, 2, 3, 4, 5 possibilities. So I would say this is 1 minus 5 over my total, which is going to be, see, I can multiply this because they're organized. So I can do 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4, 5, 6. So 6 times 6 is going to give me 36. All right, 1 minus 5 over 36. I can plug that into my calculator and I will get 31 over 36. And if I plug that into the calculator and get the decimal, it's going to give me it equals 0.861 repeating. Or if I want to put the percentage, it's going to be approximately 86.1%. All right, so this is my answer for the sum of the probability when it does not equal 6. I found it by finding the complement, or if you will, the opposite, 1 minus the opposite specifically. So I can do the same thing with my probability of the sum, which is less than or equal to 9. Well, to find the sum, or the probability of the sum of less than or equal to 9, I can find it through the complement, which is 1 minus the opposite. So I say 1 minus the opposite of the sum is less than or equal to 9. Well, obviously the opposite of less than is going to be greater than. Okay, so I can say the sum is greater than 9. And the question is it going to be equal to? Well, in the other one, in the sum is less than or equal to 9, I have equal to. The opposite of equal to is just not equal to. So I will not include the equal sign in my inequality here. So I'll just look for 1 minus the probability of the sum is greater than 9. So I'm going to look at my options and I'm going to highlight all of those possibilities that do not include 9. It has to be greater than, but not equal to. So that's going to be the 10, the 12s, 11s, and all of those. All right. So I can say I have 1, 2, 3, 4, 5, 6. I can say this is going to be 1 minus 6 over 36. This is going to give me 30 over 36, or if I reduce that, it'll give me 5 over 6, which if I type into the calculator gives me a decimal of 0.83 repeating. And if I put that as a percentage, it'll be 83.3%. And that is my answer. So again, the whole purpose of a complement is by using the opposite so that we do not have to do as much work. That's the whole purpose. And we definitely have some examples here that are not as long, if you will. It says find the complement of this event, and so you're just going to take your probability and you're going to take 1 minus that probability, which in this case is going to give me 0.55 or 55%. So this becomes my answer. Even if they give you a 1, this is going to be 1 minus 1, which is 0% or 0. All right, and this type of problem is just, it's not really possible. It's saying that the probability is 100% going to happen, and therefore the complement, or the opposite of it, is a 0% chance of happening, because it is 100% sure going to happen, apparently. And even if you're not given a decimal, you can still use the fraction. It'll be 1 minus 1/4, which is going to give me 3/4, which is the same thing as 0.75 or 75%. All right, and even if they don't give you something pretty like 1/4, you can still do the complement. 1 minus 0.03 is going to equal 0.93 or 93%. And that is our final answer. So theoretical is a perfect world. You are not really doing anything, you're just imagining it happening, okay? That's when we listed all of our possibilities. Now we're going to do something called experimental probability. And experimental probability is when we actually do it. We physically pick M&Ms out of a bag, or in this particular case, we physically spin a spinner and see what color it lands on. And so this one says each section of the spinner has the same area. The spinner was spun 20 times, and the table shows the results off to the left. And the question is, for which color is the experimental probability, okay, that's what we physically did, that's the table, of stopping on the color, the same as theoretical probability, which is just what is the probability of each color on the spinner. So the first thing I'm going to do is I'm going to look at my experimental probability, what I physically did, and I'm just going to write all of these as probabilities. So I have a total of spinning the spinner 20 times. So I would say 5 over 20, and that can be reduced to 1/4. For green, it was 9 over 20 blue was 3 over 20, and yellow was also 3 over 20. And once I'm done with that, I'm going to go over to my spinner, and I'm going to write the theoretical probability. Okay, so this is like the dice that we had. We had 1 through 6, and each one of those had a 1 out of 6 chance of occurring. So now we have the spinner. We have 4 colors. It's all equally distributed. So we would have 1 out of 4 for each of these colors. 1 out of 4 for blue, 1 out of 4 for yellow, for green, and for red. And so the question is, what out of the experiment, what we did, and the theoretical, what is possible, which one of these colors are equal to each other? So the last question, the last sentence of this paragraph is what we're looking at. For which color is the experimental probability of stopping on the color the same as the theoretical? And the answer is red. So the last example is just pulling your information from a graph or from a table of some sort. In this particular problem, it says write the probability for the given data, and it gives you U.S. adults with pets. And it says the number of adults, and then the type of pets that they had: dog, cat, fish, and bird. And the summary portion says that 2,184 adults were surveyed. 1,328 had at least one pet. What is the probability that a randomly selected pet owner has a dog? So in this particular case, we're not looking at everybody, we're just looking at the pet owners, and they said that the pet owners were 1,328 in total. So when I write this, I'm going to say, well, I want it to be dog over my total, but it's the total number of pet owners. Total number of pet owners. So that's going to be 1,328 in the denominator, and then my dogs, the number of dogs would be 916. So I plug this into my calculator. It's going to be approximately 0.68, and then I would round to 3 decimal places, except it's going to go up. So I'm just going to go to 4 for a second, and then when I do my percentage, all right, remember when you're doing this, take your decimal, it goes over 2 times. If we round our 9 here, because the next number is an 8, so therefore go up, then that would be a 10, and so that 1 would be added to the 8 in front. So I would round this to 69%. All right. Example 4.2 says write the probability from the given data. What is the probability that a randomly selected person owns a fish? So in this case, they did not specify if it was a pet owner or not. And so because they don't specify, this is going to be everybody. So if I write my fraction, it's going to be my fish owners over everybody or all. And so that means at the bottom it's going to be 2,184, and my numerator is going to be 146. Plug it into the calculator, and you should get 0.067. You round it. It's like 665 or something, or 668. And if we were to bring over our decimal to get a percentage, it would be 6.7%. And this is our answer. So same process as before. It might be a little bit easier. You just have to make sure that you're aware of what is happening in the denominator. Is it going to be just the pet owners, or is it going to be everybody? So knowing those 2 values is extremely important. If you have any questions, please make sure you email me or text me on Teams, and I hope you have a good week.